So in this video, we'll define the characteristic polynomial of a matrix M. Please look at the definition here. It's basically the determinant of the matrix lambda I minus M. And let's look at some example first. Let's say I give you such a matrix M, you see, and let's look at the characteristic polynomial of M. So basically, it comes down to finding the determinant of this 2 by 2 matrix now, and let me write it down here based on the formula for the determinant of 2 by 2 matrix. So basically, the characteristic polynomial is lambda squared minus 5 lambda, right? And let me add a couple of notes here. So let's say if M is actually having size n by n, the characteristic polynomial that you have here is actually a polynomial of degree n. And n is the same as the number of rows of the matrix M here. And the second fact of the characteristic polynomial is definitely related to the eigenvalues, right? You see, by setting such a polynomial to be 0, we can actually solve for all the eigenvalues lambda of M. So it doesn't matter much. So I understand that in the last two videos, we basically always use this polynomial equation to find all the eigenvalues. But the fact is that if you kind of swap the two matrices inside the determinant, and this characteristic polynomial, same as our definition, which is in our first box, it actually has the same root as the second one. If you understand the property of determinant well, you'll see both polynomials, when you set them 0, you'll get the same eigenvalues lambda. And anyway, that's the end of this video. We'd like to look at more properties of characteristic polynomial in a deeper way a little bit later.